Hey everybody, we're Team 2602D, and today we are going to try and teach you how to calculate torque for your robot and apply that. It's good to keep in mind that this is not by any means an exact number, it's just a good estimate. So let's get started. What is torque? Torque is a rotational force around an axle, and it's often known as like a twisty force. So the place to start when calculating torque for your arm is the motors. Our arm has two motors that are geared at a 84:12 ratio. To calculate gear reduction, you use your gear reduction driven minus driving, right? So we have a 84 tooth driven gear and a 12 tooth driving gear to get a multiplier of 7, right? Then you multiply your torque on your gear by your driven gear by the multiplier. So our torque for 393 two-wire motors is 1.67 newton meters times 2 to get 2.8 newton meters multiplied by your multiplier to get 19.6 newton meters. Now that is the torque that your gear has when driven, and that's the torque of the arm. Then we've got two towers with torque, so you can add together the two torques to get 39.2. So we've got 39.2 newton meters of force lifting. And then to calculate your torque at distance, which is how much you can lift, it's your torque equation, which is torque equals force times distance. So our torque is 39.2 newton equals our force, which is how much we can lift, times our distance, how long our arm is, or where to the center of mass of the arm is, which in our case is approximately the same. And it's 0.381 meters. And it's important to take into account this is meters, not inches. That division comes out to be, with some conversion, 23 pounds. So our arm can lift 23 pounds of force, approximately. We have some rubber bands involved, and we don't have the math for that. But this is a kind of a baseline for us to keep in mind when trying to come up with game strategy.